Let's go over the steps for constructing a confidence interval when the population standard deviation is known. The method we would use for constructing the confidence interval would be different if we didn't know the population standard deviation. So the first thing you want to do before using this method is make sure that you are given the population standard deviation. You'll want to verify that the sample is random. Verify that either the population is normally distributed or n must be greater than or equal to 30. Next, you'll want to find the sample mean if it's not given, and that will serve as the unbiased estimator of mu. You'll want to use the technique I had mentioned in my last video for finding the critical values that correspond to the desired level of confidence C. Then we'll use a formula to calculate the margin of error. Finally, we'll find the left and right endpoints of our confidence interval by subtracting the margin of error and adding the margin of error. For a 95% confidence interval, we'll be 95% confident that the true population mean lies within the margin of error. Here's the question. Assume the population being measured is the number of hours worked by grocery store employees in a county. 40 employees are randomly sampled, and their sample mean turned out to be 29.6 hours. Assume the population standard deviation is known to be 7.9 hours. Okay, so we'll take it step by step. First of all, is the sample size at least 30? For this problem, the answer is yes. We have a sample size of 40. But do we think the original distribution of hours worked by employees is normally distributed? So think about that. The answer is yes. This would typically be an example of the type of variable that would be normally distributed. There would be an average number of hours worked around which most employees would work. And some would work more, some would work less, but it is less likely for them to work more or less than average. So yes, it's typically a normal type of thing. So, regardless of whether the employee hours worked forms a normal distribution, our sample size is greater than 30. So we know that the sample means will be approximately normally distributed. Now the curve that we're going to draw here is not the original distribution. We're going to draw the distribution of sample means of size n equals 40. So we won't use the population standard deviation sigma as our standard deviation. Instead, we'll use sigma x bar. So let's go ahead and use the formula for sigma x bar to find out what the standard deviation should be for our sampling distribution. I'll do it on the side here. Okay, we want to divide 7.9 by the square root of 40. It's 1.249. Notice that it's much smaller than 7.9 hours. That's because we sampled so many employees. Okay, so let's go ahead and find the cutoffs here. It's a 95% confidence interval, so it's fairly wide. I'll shade in the tails. And we want to put C equals 0.95 in the middle. Let's go to the tables to find out what ZC corresponds to 95% confidence interval. Okay, we'll just go down here to our shortcut table. Here's the 95% confidence interval. The ZC that goes along with that is 1.96. So we can actually write those down right here. This is going to be our ZC. And then we have our negative ZC as well. Okay, now in order to create our confidence interval, let's just trace the boundary, the cutoff, up, and we put a parenthesis where those boundaries are. Okay. And if we want here, we can shade in the interval itself. Okay. That's our 95% confidence interval. But now we need to relate it to the x values. So we know that the mean of our sample was 29.6. So that's what goes in the middle. Remember that we don't really know where mu is here. It could be to the right of that, it could be to the left of that, or it could actually be 29.6 itself. Now our last step is to get the margin of error and add and subtract that margin of error from the x bar. So the formula for this is E equals ZC sigma over the square root of n. It may help to write down what we were given. So n is 40, sigma was 7.9, and we also discovered ZC to be 1.96. All of those numbers will be used here in calculating the margin of error. It's 2.45. Our last step is to add the margin of error to the sample mean to get our right endpoint. And then we'll subtract the margin of error from our sample mean to get the left endpoint. The right side of our confidence interval becomes 32.0. And the left side becomes 27.2. Now we'd like to sum up our results into a nice, concise statement. So with 95% confidence, the true population mean number of hours worked for grocery store employees in the county is between 27.2 and 32.0 hours.